All right, here is linear program example 2. So we're trying to set up an advertising plan of how many newspaper and television ads to put out. We have a budget to reach, or that we have to stay within, and we'd like to reach the most customers possible. So it's up to you to write out this linear program. If you do, it should look something similar to this. Right, where we have 6 variables. We're choosing number of newspaper ads 1 through 10, number of newspaper ads 11 to 20, newspaper ads 21 to 30, and TV ads, so on and so forth. Now, what happens is you might think, well, I'm just choosing newspaper ads and TV ads, but when you set up the objective function, you'll realize that the objective function is set up that each number you choose is going to have a different cost. So we're trying to minimize the cost, or rather we're trying to maximize the number of new customers. And so that's what's going to indicate we might have 6 different variables to choose from. With that, we have constraints. We have to stay within our budget. We can't have more than 30 ads of newspaper, more than 15 ads of TV, and each individual section should have X1, 2, and 3 need to be less than or equal to 10, because that's the number of newspaper ads. And each 4, 5, and X4, 5, 6 need to be less than or equal to 5. So with that in mind, what I'm going to do is I'm just going to grab this information here. I'm going to copy and paste this into Excel. All right, and so it looks just slightly different. And so there's where we have it. Okay, and so I'm going to insert a new column here and call this the number of ads. And so this is going to be my X1, X2, 3, 4, 5, 6. So I'm going to highlight those in blue. So those are my number of ads. Okay. Now my objective is to reach the most customers possible. So new customers is going to equal the sum product of these with my ads, meaning that it's going to be 900 times X1 plus 700 X2 plus 400 X3, 10,000 X4, 7,500 X5, 5,000 X6. And that is my objective. So some product can do that rather quickly. Now I have a budget constraint. All right, so here I have, so I can set up something here that says my budget of 145,000, and this is how much I'm going to use, which is again equal, I can use some product of the ads, comma, the X's, and so this is my budget constraint. I need to be less than or equal to that. Okay. Next is I have an upper limit on each one. So I'm going to put an upper limit, and we'll spell that word correct if we can. And so the upper limit is 10, 10, 10, 5, 5, 5. So each of these individual X's need to be less than or equal to the upper limit. So I'm going to highlight that in orange. And then lastly, I have here total newspaper, total TV, and I can't have more than 30, more than 15. This is equal to the sum of my 3 X's. Let's see if that did it right. The sum of my 3 X's here, not there, but right here. And this is equal to the sum of these 3 X's, 4, 5, and 6, right here. And so that is my last constraint there. And so with that, I'm going to now go to Solver and maximize the new customers by changing all 6 X's and add the constraints that my budget is less than or equal to the amount given to me, that each of the individual X's is less than or equal to the upper limit, and lastly, that the total number is less than or equal to 30 and 15. So I have those. I'm going to solve it simplex LP. I click solve, and here is the optimal. So I do 20 total newspaper ads, 12 total TV ads. I'm within my budget. I'm reaching 113,500 customers, and I'm within the total amount there. So I have that set up right. Let's go back to Solver. Let's solve. Let's run a sensitivity report. And here is my sensitivity report, meaning that if I increase my budget by $1, I can reach 0.625 new customers. And that's the big interpretation for the shadow price, that I need for this example. And so there you have the linear program set up for linear program example 2.